and welcome to space. And this is a model of probably the solar system's best-known comet, 67P Churyumov-Gerasimenko. It's the comet that Rosetta is flying around. Philae's down there too. It's given us some great emotional stories, but what has it taught us about science? We're going to find out, but first, some other news from the universe this month. A boost for Europe's long-delayed Galileo sat-nav system, with 2 new satellites launched and 2 others placed on the wrong orbit last year, now salvaged onto useful paths. This is Lockheed Martin's design for a new space resupply ship for the ISS. It uses elements of Europe's ATV spacecraft and a robotic arm in a semi-reusable system. And researchers from Denmark and Australia have calculated there should be billions of exoplanets in our galaxy in the so-called habitable zone, meaning places where life could exist. To our main story now, and the science of the Rosetta mission.
If I could be the one to hold you.
This comet-chasing mission is full of surprises, from the weird shape of 67P to Philae's bounce. And there could be more, because Philae could wake up.
Okay, so what you see here is a model of the comet of Churyumov with the 2 big lobes, and here is the small lobe where Philae has landed. And it has not just landed, it landed first in the area where we targeted for, but then made a huge leap, crossing this huge crater here on the smaller lobe, and ended up after several small bounces near the crater rim.
Right now, Rosetta is keeping an eye out for its baby.
We're in the process of starting to listen for the lander. We've already listened to it once, and we'll continue doing that each month to get a gauge for whether it's come back, whether it's going to be able to tell us what kind of illumination conditions are down there. And on the back of this, we're doing ride-along observations to see if we can see it on the surface as well.
Work on Rosetta is going on all over Europe. It's here in Bern, Switzerland, that scientists made the most surprising discovery of the mission so far. Many had predicted that the water on Rosetta's target comet would be like that on Earth, but they were wrong.
We have seen early on in the mission that the water that we have up there is completely different from the water that we measure here in the laboratory. This is very good proof that the comet has other water than we have here on Earth.
A previous measurement from another similar type of comet had found that its water was just like that on Earth. So the quite different result from Rosetta made a big wave in the science community.
That's a real surprise. That sends us back to the drawing board in terms of trying to figure out how did Earth get all of its water, if not from material coming from deeper in the solar system.
There are other surprises too. The comet's surface has what looks like cracks, boulders, mountains, craters and ripples. But one should keep in mind that this is a truly alien world.
I would actually really love to be there on this surface, so standing in the neck region, look up the cliff, really stretching 700-800 meters up, really steep up there, very rough terrain, and then all this smooth area in this happy region, and then the cliffs are so in surf.
If I felt it with my fingers, of course it would feel very, very cold. But besides of that, and that's partly surprising, it's hard material. It looks a little bit like rock. It is not rock. It is some icy material with dust, with organic compounds, but it's hard, porous material.
And what makes the scientists' work even more fascinating is that the comet is constantly changing.
You have to imagine that the comet undergoes a huge amount of thermal stress. It gets heated during the day up to maybe 50 degrees centigrade, and then during the night it cools like crazy down to minus 200 and possibly below. This generates cracking on the surface and breaking the surface apart through thermal fatigue.
These are exciting times for the Rosetta science team as the spacecraft captures images, dust and gas every day as it flies alongside the comet this year. And of course they're getting ready, just in case Philae shows signs of life.
The next step would be to be close enough to the sun that the lander gets warm enough so we can recharge the battery, and then we can do much more sophisticated scientific sequences, maybe including drilling again.
Last November the drill couldn't reach the surface, but that could change.
The images that we took show that if we slightly turn Philae on its feet, then the drill will have access to these materials, which the images show to be the most fabulous we could imagine, because in these materials there are all these original blocks of ice filled with organic molecules within our grasp.
So, Rosetta is keeping everyone busy.
We download daily data from our instrument flying on Rosetta. And then we have to look at all this data. So that's a job that really takes you 7 days a week.
If I could be the one to hold you.
Now we're in the middle of the science. We're in the do or die in a way. It's basically, there are things happening now that if we decide on a certain operational procedure or a certain observation, we will lose the opportunity to ever make that measurement again. Because of the evolution, we're only here once.
Break the dam, let the river flow.
In 2004, Rosetta and Philae set out to catch a comet. What they're doing over a decade later is rewriting our understanding of how the solar system formed in surprising new ways.
Let the river flow. Break the dam.
Now to the next episode of the Astronaut Academy, our regular series, but we're leaving Cologne this time and heading to the ISS, where Samantha Cristoforetti has given us a unique insight into the real working life of an astronaut.
0.06, bridge rate. Target is on. Space just provides this unique environment, weightlessness. As soon as we opened the hatch of Dragon, I immediately retrieved samples for an experiment, an ESA experiment called T-cell, about the activation of immune cells in microgravity. Those cells had to be taken out of Dragon immediately because they were in cold storage and they would degrade. And so we had a very strict timeline, and we were able to perform it successfully. You just happen to find out things that happen in space that you did not know about, and that's even more exciting because it opens up new questions and new possibilities of discovery.
That's wonderful, thank you.
That's it for now. Next month, we're going to have a look at how satellites are filling in the gaps in our knowledge of the oceans. See you then.